I will do 4, 5, 6, and 7 in one video here together. These are all Minitab outputs. A Minitab is just statistical software, just like SPSS is statistical software, just like Excel is software you can do statistics with, just like the TI-83 is a calculator you can do statistics with. It's just a tool for calculating, organizing, displaying, doing statistics, right? So that's what Minitab is. So this is just the output, typical output you would see from a Minitab operation, a Minitab calculation. So in this case, the Minitab output presents a 95% confidence interval. So there's some values in here. So the assumed sigma, the assumed population standard deviation is 9.1108. The variable is x. N, the number of values, is 64. The mean, 53.605. Now this is our sample mean, right? This is based on the sample information that we input into the statistical software. Sample mean is 53.605. And SE mean, that's the standard error of the mean. I'll write that. Standard error of the mean. That's that 1.1389. And in a further problem, we'll discuss how that standard error of the mean factors into creating this confidence interval. So here, 95% confidence interval. This output is very similar to the output that you see in the TI-83-84 graphing calculator, right? Where you see the endpoints of the interval as an ordered pair. So in this case, the 95% confidence interval would be 51.373. It's less than my population mean, is also less than 55.837. So this is saying we believe the real population mean is between 51.373 and 55.837. How confident are we? Just like problem number 3. We're 95% confident that the population mean is between 51.373 and 55.837. That's just typical confidence interval talk. Okay, scrolling down a little bit to number 5. Following Minitab output presents a 95% confidence interval again. So now this says, use the appropriate critical value along with the information in the computer output to construct a 99% confidence interval. So we have a 95% confidence interval. Well, we want a 99% confidence interval. Okay. So let's go to the formula sheet and look at what information we need in order to create a confidence interval. Okay, so pulling up the formula sheet, important formulas. Chapter 7 is confidence intervals. So we've got Z confidence interval for means and T confidence interval for means. Which one are we talking about? We have an assumed sigma here. We have something that we think is sigma. So this is the population standard deviation. So let's use Z, because Z we use when we know the population standard deviation, normally distributed, or n is greater than or equal to 30. In this case, n is 54. Let's go for it. So here's the formula here, or the Z confidence interval. X bar, sample mean, minus the Z alpha over 2 times sigma divided by the square root of n. Now this might be familiar if you look back at chapter 6. Look right here. Whoops. That's actually the standard error of the mean. This sigma divided by the square root of n, that's the standard error of the mean. So this little piece here is the standard error of the mean. That's important for us, right? And then on the other side, it's the sample mean plus that. Sample mean plus that, right? Okay. So I'm going to rewrite this formula here. So X bar minus the Z alpha over 2 times sigma divided by the square root of n. It's less than my mean. It's also less than X bar plus all of that. Z alpha over 2 times sigma divided by the square root of n. Okay, perfect. So we have a lot of information here, but the one piece of information we really need that we don't have is the 99% confidence interval. Now, if you remember confidence intervals, that's a two-tailed. That's two tails, right? Two tails. So 99% confident. We want to be 99% confident that the population mean is in here. So each of these tails add up to 0.01. So we've got 0.005 in each of these tails. Yes? 0.005 in each of these tails here. So in order to determine this Z alpha over 2 value, in order to determine these two values, positive and negative, I need to go to my Z table and look for 0.005 on, the table gives me the values to the left. I'm looking inside the table for 0.005, and that'll give me this Z value here. So let's pull that up. Z, 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 Z. Let me scroll down faster. Z. We're looking for 0.005. Here we are, 0.0051, 0.0049. I'm going to choose this one. It rounds up. Negative 2.58. Okay. So that means this value here on the left is negative 2.58. This value here on the right is positive 2.58. Those are my Z alpha over 2 values. If it was a 95% confidence interval, each of these would be 0.025, because that adds up to my 0.05, my 5%. Go to the table for that, and there we go. Okay, so let's plug these values in. Let's substitute these values in and see what happens. X bar, sample mean, 49.085 minus 2.58. Now remember, we looked at the formula sheet. This is the standard error of the mean, which is the number we have it here. They give it to us. This Minitab output gives us the standard error of the mean. So we just multiply by 1.3785. That's my left side. I'm going to have to squeeze a little bit from my right side. Oh, I don't have to squeeze. Let me just move over. So X bar, 49.085 as the ambulance rolls down 59th Street, plus 2.58 times standard error of the mean, 1.3785. I'm going to put this right in my calculator, see what happens. So let's clear that out. 49.085 minus 2.58 times 1.3785. I didn't put the 5. 49.085 minus, let me make sure that's right, 2.58 times 1.3785. Enter. 45.528. Let's write that in here. 45.53 around, whoops. 0.53. And then to get the other endpoint, I'll just hit second entry, re-enter that, and then change that to plus 52.641, 52.64. And that's my 99% confidence interval there. Okay, moving on to number 6. The following Minitab output presents a 95% confidence interval again. We got all the values. We know what's happening here. Find the sample size needed so that the 95% confidence interval would have a margin of error of 1.4. Okay, so let's go back to the formula sheet. Let's go back up to chapter 7. Aha, 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 aha. Here's the formula for the sample size for means. So this is the sample size for means here. So we use this formula to determine the sample size that we need. And it says where E is the maximum error of the estimate. That's another way of saying the margin of error. Exactly the same thing. So N equals Z alpha over 2 times sigma over E squared. Okay. So N, my sample size, is equal to Z alpha over 2 times sigma divided by the margin of error squared. Okay. So let me just double check that formula, make sure we wrote it in properly. Yes, yes, Z alpha over 2 times sigma over E squared. Let's substitute what we know. Z alpha over 2. Well, I don't know that yet, right? This is for a 95% confidence interval. Again, if we remember, confidence intervals are two-tailed. Two-tailed, right? We want this area in between here to be 95% of the area under the normal distribution. So each of these, that's 0.5% divided by 2, 2.5%, 0.025. So I look at the table for 0.025. Table will give me the area to the left. Trusty z-score table, 0.025, where art thou? 0.025, there we go, exactly it. Negative 1.96. So here, negative 1.96, positive 1.96. So that's going to be our Z alpha over 2. We'll just use positive 1.96. Because we're going to square this at the end of the day, so it's all good. So you can use either. So 1.96 times sigma. Assume sigma is 112.4105. Now the margin of error, they give it to us, 1.4. And then we're squaring all of this. I'm pulling out my calculator for this one. Let's clear this. So in parentheses, 1.96 times 12.4105 divided by 1.4 squared. 301.88. Oh gosh, what'd I do? I pressed something funny. 301.88. So my sample size needs to be this big in order for the 95% confidence interval to have a margin of error of 1.4. Now I can't have this many people, so let's go up one to 302. That's what I need to have, at least what I'm looking for there. So N equals 302. That's the sample size I need. Number 7, another mini-tab output, another 95% confidence interval. Same kind of question. Find the sample size needed. N equals Z alpha over 2 times sigma divided by the margin of error squared. So that the 99% confidence interval will have a margin of error, an E, of 1.1. So in this case, where we want a 99% confidence interval, so we want 99% of the area to be in here. You might remember we did this a little bit before. 1% divided by 2 is 0.5%, or 0.005. That's what I'm looking at the table for. I go to the table for 0.005. That was right here. We use negative 2.58. Right? We did this one before. Negative 2.58. You can also memorize those values. 90, 95, 99. If you memorize those values, you should be good to go. It helps. So n, so we've got 2.58. That's my z alpha over 2. Times sigma 11.6084 divided by the margin of error 1.1 squared. So we have 2.58 times 11.6084 divided by 1.1. Since this is all multiplication and division, I don't need to put my numerator in parentheses. If I had some addition and subtraction in here, then I would have to think about that. Or if this was a complex fraction, then I would have to group a little bit better. Squared 741.30. Right? I got everything in there. Yeah. Did I round properly? Let me look at that again. 0.31. Let's say 0.31. So n is 742.